Okay, so when looking at these two molecules, this molecule will be the base and this molecule will be the acid. This is because the base has electrons, lone pairs of electrons that can accept protons or accept hydrogens, while acids donate protons. And because this is an acid, it has protons to donate, which are these H's. And again, so a base will attack the protons while the acid will give those protons to the base, which is why this is the base and this is the acid. So when we draw our arrows in, the sulfur lone electrons will attack one of these hydrogens and the hydrogen will give up its electron pair. The reason that the nitrogen gives off its, the nitrogen lets go of the reason why the hydrogen, we take the hydrogen off of the nitrogen is because there's a big electronegative, because nitrogen is so electronegative that it creates a partial positive charge on these hydrogens. And we want that partial positive charge because that way sulfur can easily come in and take that hydrogen. That's why we don't take it off of any of these carbons, because again, there's not that partial positive charge on any of the hydrogens here, because again, carbon isn't very electronegative, so it's not pulling those electrons toward itself as much as nitrogen is. So again, that's why we take the hydrogens off of this nitrogen and not the carbons, because of that electronegativity difference. So the products would look like this. We always have to make sure that we conserve our charge. So since we have a negative charge on this side, we have to make sure we have a negative charge here. And that negative charge will be on the nitrogen because we've just added 2 more electrons to it. So the formal charge will be 1, 2, 3, 4, 5, 6. 5 minus 6 is negative 1, and that's why we have, and we look and we have a negative charge here and a negative charge here. So then when we look at which one's the conjugate base and which one's the conjugate acid, since this is the base, this one will be its conjugate acid. And since this is the acid, this will be its conjugate base. So now we want to identify, okay, so what is the strong acid, strong base, weak acid, weak base? And to do that, we're going to use ARIO. And we're going to look specifically at the bases. So whenever we're looking at to see which base is the weakest or the strongest, we're going to see where the negative charge lies. So we have a negative charge on this sulfur and we have a negative charge on this nitrogen. From there, we're going to compare using the atom effect, so the A in ARIO. So we look, okay, since sulfur is more electronegative, it can pull and hold that negative charge a lot better than the nitrogen can, making it a more stable molecule, making it a more stable base than this one over here. So since it's more stable, it's going to be a weaker base. It's not going to react as readily as this base over here is. Because this nitrogen is a little more unstable, it's going to react a lot more readily, and we're going to consider that a strong base. So this is a strong base, this is our weak base. And from there, we can see, okay, so if it's a weak base, then we know that its conjugate acid is going to be a strong acid. And we know that if this is a strong base, we know that its conjugate acid is going to be a weak acid. Okay, so now we need to determine which acid will have the higher pKa. So acids that have a higher pKa are considered less acidic. So we have to see, okay, this is our strong acid, this is our weak acid. Since this is our weak acid, it's going to have a higher pKa value than this is. It's not going to have as much hydrogen concentration as this one is, which makes its pKa value a lot larger. And when we look at the equilibrium position, we're again going to consider our bases. The equilibrium will lie to the side that has weaker molecules, so like a weaker base. So since the reactant side has the weaker base, equilibrium will favor the left side, the reactant side, because again, we have a weak base over here, which is a lot more stable. Equilibrium favors the stable side. So we can predict that at equilibrium, these two species will be at highest concentration.